What if I told you there's a black hole 400 million times heavier than our sun found hiding in plain sight? The Webb telescope just dropped a bombshell discovery that's rewriting everything we thought we knew about the universe. You won't believe what this means for black holes and how galaxies form. Stick around because this changes everything. So what led astronomers to discover this one? Using the powerful tools of the Webb telescope, which can see in infrared light, researchers examined the galaxy that hosts this black hole. They found unusual patterns in the light coming from the galaxy, subtle hints that something enormous and quiet was hiding at its center. These patterns provided clear evidence of a strong gravitational force, which is a telltale sign of a black hole's presence. What made this discovery especially intriguing was what scientists didn't find. The typical bright light from material being pulled into an active black hole wasn't there, confirming that this one is indeed dormant. Finding it was like noticing a shadow in a brightly lit room, a testament to how precise the Webb telescope is at revealing hidden parts of the universe that we couldn't see before. Now, let's talk about the size of this black hole. If our sun were the size of a small marble, this black hole would be a massive sphere nearly 3 kilometers wide. That's really hard to imagine. What's even more interesting is that this black hole is in a sort of hibernation. It's barely consuming material and is operating at only 1% of its maximum feeding capacity, known as the Eddington limit. This suggests that it may have experienced a rapid growth phase in the past and is now resting after having feasted on a lot of material. And the story gets even more surprising from here. Scientists have made a groundbreaking discovery concerning an exceptionally large black hole situated within a smaller, less explored galaxy. This black hole is remarkable, comprising approximately 40% of the galaxy's total mass, a staggering contrast to the norm, as most black holes in our universe typically account for merely around 0.1% of their host galaxy's mass. This striking divergence has prompted researchers to reevaluate long-standing beliefs regarding the formation and evolution of black holes. Traditionally, it has been posited that black holes and their accompanying galaxies evolved together over cosmic time, with black holes gradually accumulating mass as they pull in surrounding gas, dust, and stellar remnants. However, this new finding challenges that paradigm, suggesting that black holes may have formed and significantly matured long before their host galaxies began to take shape, or even in isolation from them entirely. Such insights open up a wealth of questions about the conditions of the early universe, an era characterized by extreme chaos and rapid changes, during which black holes may have played a far more critical role than previously recognized. In past models, scientists have maintained that black hole growth is a gradual process, governed by a delicate balance between the inward pull of gravity and the outward pressure stemming from energetic radiation and gas ejections. Nevertheless, the newly identified black hole defies this conventional wisdom. Its astonishing mass, especially given its existence in the relatively short time frame following the Big Bang, suggests a formation story that is not only unique, but also rapid and possibly tumultuous. This discovery invites further investigation into the mechanisms of black hole formation and their potential impact on galaxy evolution in the nascent universe. One idea is that this black hole went through a feeding frenzy, rapidly consuming gas and matter at a pace much faster than we normally expect. After eating a lot, it may have entered a calm phase where it stops growing for a while. There's also a more radical theory suggesting that some black holes may have begun as large as they are now, forming from massive clouds of gas collapsing together instead of starting small as remnants of dying stars. This idea could explain how such big black holes appeared early in the universe's history. Researchers are now running simulations to explore these theories, as they could change our understanding of black hole formation entirely. This discovery doesn't just impact our knowledge of black holes, it also influences how we think galaxies formed and how stars evolved, as well as the behavior of mysterious substances like dark matter and dark energy. Perhaps the most intriguing part of this discovery is how this black hole interacts with its galaxy. It suggests that black holes might have played a significant role in shaping galaxies instead of merely existing quietly at their centers. This challenges the long-held belief that black holes and galaxies evolved in harmony. Instead, it opens up a fascinating new idea that black holes could have been instrumental in forming galaxies from the very beginning. Notably, this particular black hole stands out not just because of its size, but also due to its dormancy. Most other black holes from this early time in the universe's history are actively feeding and glowing brightly, making them easier to spot. But this quiet giant hints that there could be many more dormant black holes lurking out there, just waiting to be discovered by powerful telescopes like the Webb telescope. If dormancy turns out to be a common phase in a black hole's life, it could change how astronomers search for these mysterious objects in the universe. They also experience prolonged periods of quiescence. This revelation could significantly alter the approach scientists take in their search for black holes, prompting a shift in focus from solely the bright, active black holes to these hidden, dormant titans. Dormant black holes may even play a crucial role in the stabilization of galaxy formation. In the absence of the disruptive forces associated with intense accretion, such as high-energy jets and intense radiation, galaxies could undergo a more gradual and steady evolution. This stability allows galaxies to develop without the violent interruptions often caused by their more active counterparts. Gaining a deeper understanding of this balance could lead us closer to unraveling the complex history of galaxies, including our own Milky Way. Interestingly, this isn't the first time we have encountered black holes in a dormant state. Within our galactic neighborhood, the Gaia BH3 black hole was identified by the European Space Agency's Gaia mission. With a mass approximately 33 times that of our Sun, Gaia BH3 is classified as inactive. It lacks a companion star from which to accrete matter, which renders it exceptionally challenging to detect. In stark contrast, the black holes formed in the early universe present an entirely different scenario. These primordial black holes are significantly more massive and formed when the universe was less than 1 billion years old. To put this into perspective, Gaia BH3 exists within a relatively mature galaxy that has developed nearly 13.8 billion years after the Big Bang, underscoring the staggering difference in their formation epochs. This discovery compels scientists to grapple with fundamental questions. How could such gargantuan black holes form in such a brief period? What specific conditions facilitated their growth? And what insights can this provide about the chaotic and unpredictable nature of the early universe? These probing questions are driving astronomers to delve deeper into the mechanisms of black hole formation and the unique cosmic environments that give rise to them. A black hole of this magnitude is not easily overlooked, much like that subscribe button. Click it now before this astounding revelation pulls you in.